2 mole of monoatomic ideal gas is heated from 27 degrees C to 127 degrees C at atmospheric pressure. What is the heat absorbed by the gas? We can solve this question by using the first law of thermodynamics, which is Q equal to delta E TH plus W, where the Q is the heat absorbed by the gas, delta E is the internal energy change, and the W is the work done. Since the temperature of the gas is increased from 27 degrees C to 127 degrees C, so there is a change of the internal energy of the gas. And to calculate this internal energy change of the gas, we use NCV delta T, where N is the number of moles, CV is the molar specific heat at the volume at the constant volumes for the gas. Delta T is a change of the temperature. And this W, we can use P delta V because in this process, the gas is heated at the atmospheric pressure, means 1 atm. So the pressure is constant. When the pressure is constant, it is an isobaric process. Then we can use this formula P delta V to calculate the work done, where the P now is the pressure is a constant. Okay. The CV value for the monoatomic gas is 3 over 2R. So that's why now in the first term we have 3 over 2 nR delta T. And for this P delta V, we have to change it to nR delta T based on the equation of state or ideal gas law, which is a PV equal to nRT. So because there's a change of the T, it causes the volume change whilst the pressure remain constant. So P delta V can be substituted or replaced by this nR delta T. Okay, because in this question, so why we need to take this this change is because the delta V, the change of the volume, is not given in the questions, but we have this change of the temperature. That's why we need to express the P delta V in the form of nR delta T. Now, because these two terms are in terms of nR delta T, so we can add them up to get this 5 over 2 nR delta T. Now we can substitute value to get the Q, where the N is the number of mole. It is 2 mole, R is a gas constant 8.31, and the change of temperature is 127 minus 27. So because this is the delta T, not the T itself, so that means to find the delta T, we do not need to convert the temperature into kelvins, because either we, no matter we convert or not convert to the Kelvin, the answer will be the same for the delta T. So now we have the answer for this Q, the heat absorbed by the gas, is 4,155 joule. We have another ways to evaluate this Q. Instead of using the first law of thermodynamics, now we can use this formula Q equal to NCP delta T. This is the heat provided to the system when the gas is heated at the constant pressure. CP means molar specific heat at the constant pressure. This one is NCV, is the molar specific heat at the volume constant. So since this system happens at the constant pressure, we can use this formula to directly calculate the Q instead of using the first law of thermodynamics. And because this Cp value for this monoatomic gas is equal to 502R, so if we substitute this Cp by 502R, we will get 502 nR delta T, which is the same as these expressions, the fourth steps in the first method. So that means now we can see that actually we have two ways to calculate the Q, the heat absorbed by the gas, and we should get the same answer.